Imagine a rock weighing hundreds of kilograms, suddenly moving across the ground by itself. Welcome to a true scientific detective story. Today, we're diving into this explainer to solve one of the most visually striking and enduring mysteries in all of geology.
Seriously, think about the facts for a second. We're talking no heavy machinery, no animals pulling them, and absolutely no human intervention. Just raw, completely unexplained motion across a totally barren landscape. It's wild, right?
So what exactly is causing these rocks to move? Well, the scene of the crime is Racetrack Playa, way out in Death Valley National Park. It's this vast, incredibly dry lake bed that is literally littered with stones. But the crazy part is they leave these incredibly long, perfectly synchronized trails etched into the mud right behind them, which totally begs the question, what on earth is pushing them?
To really grasp the sheer scale of this, let's talk about weight. Up to 320 kilograms. That is about 700 pounds. To put that into perspective, that's like a large vending machine just going for a stroll. And these massive boulders can sit completely motionless for years, sometimes even decades at a time, before mysteriously deciding to move.
Now, for decades, people threw out all kinds of wild guesses. I'm talking hurricane-force winds, incredibly thick ice sheets, and yeah, some people literally thought it was magic or some bizarre magnetic anomaly. But over time, scientists slowly gathered the evidence to rule out the impossible. It's been a long journey, from the very first scientific report back in 1948 to a famous corral experiment that actually challenged the ice theories in 1976, all the way to high-tech GPS mapping in the year 2000.
Section 1. The scientific stakeout. Catching the rocks in the act.
You see, just mapping the trails after the fact wasn't cutting it anymore. So between 2011 and 2014, researchers turned this desolate landscape into a full-blown, high-tech surveillance zone to catch these rocks red-handed. They set up continuous weather stations and hourly time-lapse cameras, but the real stroke of genius, they custom-built GPS loggers, embedded them directly into bored-out limestone blocks, and placed them right about magnetic triggers buried in the mud. It's like a geological sting operation.
And you know what? That stakeout paid off in a massive way. December 20, 2013. That was the huge breakthrough. Scientists directly observed an event where over 60 rocks moved simultaneously across the playa. 60 rocks.
Section 2. The ice raft mechanism. Breaking down the crime scene.
So we finally have our whodunit, and it turns out it's not a single violent force pushing them, but a highly fragile, incredibly specific chain reaction. It goes like this. Step 1. Winter rain and snow create a very shallow pond on the dry lake bed, maybe just a few centimeters deep. Step 2, sub-freezing nighttime temperatures form a thin sheet of what they call window pane ice right over that pond. Step 3, the bright morning sun comes out, melts, and fractures that ice into large floating panels. And finally, step 4, steady light winds, we're talking just 4 to 5 meters per second, push those floating ice panels, which then bulldoze the rocks.
But here is absolutely the most surprising clue of all. The ice panels driving these massive 320-kilogram rocks, they're only 3 to 6 millimeters thick. That's thinner than your smartphone. That completely shatters the old myth that thick, highly buoyant ice was floating the stones off the ground. No way. It's just a remarkably thin sheet acting almost like a sail.
And the custom GPS data proves exactly how this whole thing unfolds. You'd think it's a high-speed crash, right? Actually, scratch that. It is a slow, stealthy crawl. On December 4th and December 20th, rocks weighing around 15 kilograms were recorded moving at just 2 to 6 meters per minute for about 10 to 15 minutes. Honestly, you would barely even notice it happening if you were standing right there.
Section 3. Leaving long trails behind. Why did the tracks look the way they do? Now you might be wondering, if the rocks are slowly being pushed by thin ice underwater, why do we see such distinct trails left behind later? Well, it's all about the rock's profile. Moving rocks have a higher profile that catches those floating ice panels, effectively getting bulldozed forward. But the stationary rocks, they have a low profile, allowing that incredibly thin ice to simply float or slide right over the top of them without snagging at all.
And what about those famously parallel tracks? That happens because a single massive sheet of ice, sometimes tens of meters wide, can push several rocks in perfect synchronized unison. But when that delicate ice suddenly hits a stationary rock or just fractures from the sun, the pads can decouple or turn abruptly. As they move, the rocks carve deep grooves into the saturated mud underwater. We just don't see the whole shebang until the shallow pool completely evaporates weeks later.
Section 4. A rare natural phenomenon. The perfect storm of conditions.
It literally took scientists decades to record this because the mechanism is just so incredibly fragile. I mean, think about the odds. It requires specific winter precipitation to flood the playa. It needs the exact sub-freezing night temperatures to form the ice. It relies on a bright morning sun to crack it, and it demands steady, light breezes to move the ice before it melts. If it's too warm, no ice forms. If the wind is calm, it melts in place. It truly is a rare, perfectly timed orchestration by nature.
If a mystery this massive can hide in plain sight for decades, it really makes you wonder, what other incredible phenomena are out there right now, just waiting for the right scientific stakeout to be solved? Ultimately, what you should take away from this explainer is exactly this. The rocks aren't moving by magic. Nature is simply using ice, water, and wind.